Hello, I want to go over this LeetCode code question, final array after k multiplication operations. So essentially we have a vector of numbers, array or vector of numbers. We have a k, so the amount of times we want to loop through it, and the multiplier. So essentially what we're doing is we're finding the smallest element within the vector each time and multiplying it by 2. Um, k, in this example, k amount of times, which is 5. So in our first operation, we'd find the smallest one within here, which would be the 1 right here. Multiply it by 2, we get 2. Now within this vector, we find the smallest one, the first smallest number, which is 2. Multiply that by 2, we get 4. Then we do the same thing, find the smallest number here within this vector, which is 2. Multiply by 2, multiply that by 2, we get 4. Find the smallest vector within this, smallest element within this vector, which is 3. Multiply by 6. Next, find the smallest element here in this vector, which is the first 4 right here, and multiply that by 2. We get 8, and that would be after the 5 iterations. So here in this code, I have everything set up. You're going to need vector q functional. Um, and I just have this. This is their example right here with the same numbers. So here we're going to define something called using, and we're going to call it of ints, pair of ints, and this is going to be equal to SED pair, int. Um, so essentially this is kind of like making your own data type, I believe, from what I've like researched. And every time you use pair of ints, it's going to be of this type right here. So it's going to be declaring an STD pair int int. So this is going to be uh a pair of int int, right? Now after this, we're going to use STD priority queue. And within this queue, we're going to define pair of ints, um, and then an STD vector of pair of ints, and then STD greater pair of ints. And then we're going to call this PQ for priority queue. So, um, this means that it's going to be of pair of ints. So this, we're going to have a vector of pair of ints. So int, and then a greater pair of ints, which means it's going to be um, from least to greatest. So from smallest number to the biggest number. Um, so after this, we're going to initialize the PQ. So we're going to have the priority queue. So we're going to have I is equal to 0, while I is less than nums dot size I plus plus. And then we're going to say PQ dot push, because we want to push this value, um, nums at array I, so the actual number, and then the index I, right? Uh-oh, I think I needed to be brackets instead. There we go. So now the priority queue has been initialized, so then we need another for loop for int I is equal to 0. Now this is going to be doing the k amount of operations. So while I is less than k, I plus plus, we're going to say auto. So it automatically detects what kind of data type we're using. And we're going to say value index is equal to top, or PQ dot top. So the first pairs within the top of the priority queue, then priority queue dot pop. So pop that value out. And then we're going to say value times equals multiplier. And then we're going to push the value and the index back into the queue, right? So PQ dot push value index. Uh-oh, value. So this pushes it back into the queue. once we're done multiplying it, and it's keeping the same index, so we know where the position is within the vector, right? So now to put this back into the nums vector, we're going to say while PQ is not empty, we're going to say auto again, auto value index is equal to the top of the PQ, so PQ dot top, and then PQ dot pop. So pop the value out, pop the pairs out, and then we're going to say nums at array what at array index is equal to the value, current value at that index, right? So this is just pushing the numbers back into their original index after we did the multiplying, right? So here we are going to say return nums. So return the vector of nums. Now here, this is our original vector, which is 2, 1, 3, 5, and 6. After the first 5 iterations, this should be 8, 4, 6. Wait, are those even the right numbers? Yeah, 6, 5, and 6 again. So here we're going to say std vector of ints new vector is equal to solution dot get final state. And here we're going to pass in nums k and then multiplier. And now we're going to say stdc out, or we should say for int num within nums std cout num followed by a space. So if we run this, as you can see right here, in my previous attempts, it outputs correctly, right? So 84656, 84656. And if we do this one, we can do this one as well. We can test it out. 1, 2. K is 3. Multiplier is 5. If we run it, 16 and 8. Multiplier should be 4. Sorry, scared me. About to say my code not working. There we go, 16 and 8. And now if we put this into LeetCode, we can see that it passes. So let's run it. Submit it. And yep, there we go. So hope y'all enjoyed. I'll be doing the explanation on my iPad right now. All right, this is the code from the final array state. So in our function get final state, we were passing a vector of type int, and then k integer, and then m for multiplier. In our example, we passed in for k 5, I believe. So 5 and then 2, and then this was 2, 1, 3, 5, 6. So we used using pair of ints. So we said using, and then we just named it pair of ints is equal to std pair int. So essentially, it's kind of like making your own data type. So you're essentially using another data type, but you're giving it the name of pair of ints. Essentially, like making your own little custom
data type with already existing data types. So every time we call in pair of ints, it's going to be of type std pair int, right? So after this, we had the priority queue. I don't even know how to spell priority queue. And then here we pass in the pair of ints, vector of type pair of ints, and then something called greater, and then it was of type pair of ints, pair of ints. So here what we're saying is that this queue is going to be of type pair of ints, which is essentially just two pairs, or a pair, std pair of int. Then we're going to have a vector of pair of ints, which is to keep hold of the elements that we pass in, so the value and the current index of the element in our current element in our vector. And then greater of type pair of ints is used to sort the queue from in ascending order. So from smallest to largest. So like this, 1, 2, 3, 4, 5, right? So that's essentially what this queue is, right? And this was called PQ. So in our first for loop, we had for int I is equal to 0, while I is less than nums dot size, which in our example is 1, 2, 3, 4, 5. I plus plus. So here we are essentially just initializing the queue. So we're pushing all the elements into the queue. So we said pq dot push and then brackets nums at array I, which is the actual value of the current element, so the actual number value, so 2, 1, 3, 5, and 6, and then comma I, which is in charge of the index, the current index of the element in the vector. So essentially, if in our first iteration we had 2, let's say 2, 1 for the whole thing, right? So 2 we would be passing in like this, 2, 1, 2, 0, sorry, not 2, 1, 2, 0, which this is the value and this is the index. Then it's 1, 1, 3, 2, 5, 3, 6, 4. That's essentially how we're passing it into the vector. So that's for this first for loop. In our second for loop is where we're actually going to be multiplying the value and then pushing that back into the queue. So we say for int I is equal to 0, while I is less than k, which is the amount of times we have to do the operations, I plus plus. So we said auto, which is going to be it's essentially just going to automatically detect what kind of data type we're using, and in this case it would be of type pair of ints, which in turn is just std pair int. So auto, and we're going to name it auto, and then we're going to have value, and then index, because remember, what did we say here? This is our value and these are our indexes, right? And then we're going to say this is equal to qp dot top, right? qp dot top. And remember when I said about greater, this essentially is going to be automatically how how do I say it? Automatically sorting itself from in ascending order. So technically, this isn't how it's inputted, or this is how it's inputted, but it's going to be updating itself. So it'd be ordering itself in ascending order by the value number. So in turn, the queue would actually look like this. So 1, 1, 2, 0, 3, 2, 5, 3, 6, and 4. So this is actually how our queue looks like, right? So then we say PQ for priority queue dot pop. So we're popping the first element out, and we say the value of the current current element within the queue, which is 1, 1. So 1, 1. This is our top, right, that we just popped out. Value, which is this one, value times equals 2, or I should say m for multiplier, which is actually 2. This is value is now 2, right? 2, 1. And we push this back into the vector. We said value times, let me rewrite this. Value times equals m for multiplier. And then we say PQ dot push value, I should say, sorry, bracket value index. So the current value and its current index, right? So this is then going to pop this back into this vector, or this queue, and it's going to automatically sort itself out again. So essentially we would have now 2, 0, 2, 1, 3, 2, 5, 3, 6, 4 for our next queue. So this would be for the first iteration. Now for our second iteration, we'd be using the top again, which one is it? 2, 0 now. So we say 2, 0. And then we say 2 times equals m for multiplier. Now it's 4, 0. Now we push this back into the vector, or into the queue. So now we would have 2, 1, 2, 1, 3, 2, 4, 0, and 5, 3, 6, 4. And this is our third iteration. We're still not yet quite at 5, right? So now for our third, 1, 2, 3, fourth iteration, we use the top again, which is 2, 1. So now we say 2, 1. 2 times equals m. We get 4, 1. Push this back into the queue. Reorders itself. So now we have 3, 2, 4, 0, 4, 1, 5, 3, 6, 4. This would be our 1, 2, 3, fourth iteration, but technically these are still indexed at 0. So this is 0, 1, 2, 3. Now we grab the top one, which is 3, 2. And then we say 3, 2. 3 times equals m, which is 2. This is 5, 5, 2. It orders itself again. 4, 0, 4, 1. What did we say it was? 5, 2. 5. Oh, sorry, I'm tripping. This is 6, not 5. 6, 2. 5. Now it's 5. 5, 3, 6, 4, 6, 2, right? And then this would be number 4. And then for the final one, we do this top one now, which is now 4, 0. 4 times equals m, which is 2, 8, 0. And then push this back in. So now for the final vector, or final q, we have 0, 4, 1, 5, 3, 6, 4, 6, 2, 8, 0. So this would be our final q. Those are after the 5 iterations, right? After we do this, we have our while loop now. Our while loop states that while q is not empty, pq dot empty. So while it's not empty, we're going to say auto again. Auto value index is equal to what? pq dot top. Right? So we'd be grabbing, after all that, we'd be using this queue to push the numbers back into the nums vector. We pop the current top, so pq dot pop the element, and then we say nums at array index is equal to value. So remember, our nums vector was originally 2, 1, 3, 5, 6, right? So we come here to the top, which is this one, 4, 1. We pop that out. Pop that out. We then push the current this current value into that current index, with nums at current index is equal to the current value. So this is essentially saying change whatever's at element or index 1 to 4. 0, 1, 2. Let me change the color. 0, 1, 2, 3, 4. So we change 4, 1 to 4. Right? And then we move on to the next element within the queue, which is this one. Uh-oh, not delete. Which is this one. Pop that out. Now we're going to be using this number. Now it says go to index at 3. Remember, this is IDX, and then value. I'm going to just say val, index and val. So now we go to index 3 and change that to a 5. Which one's index 3? This one. So it just stays the same. We're just pushing the same value back in. Now we grab the next one. Pop that out. What is this saying? Go to index 4 and then push 6 into it. What says index 4 already? 6. So we just pushing in the same value. Now we come back to the queue. This is the top. Push that out, or pop that out. And what is this saying? Go to index 2 and push 6 into it, which is the 3, and then we're going to push 6 into it. Now, finally, this is our last queue before it's empty, or this is our last element within the queue before it's empty. And now we're saying push at index 0, 8. 8. And now we have the new vector in the same positions as the original ones after we did all the multiplications. So this is our answer right here, which is the same as in the code. Hopefully you guys understood what was happening. I honestly don't know my Q's and stacks like that. So this was good practice for me as well. It took me a bit to understand. I might have tripped up on some stuff. Like I said before, I don't really work with Q's and stacks. But hopefully you guys enjoyed and understood.